Okay. So then I want to draw your attention to the invited speaker, Dr. Harald Clahsen from Potsdam Research Institute for Multilingualism. He's such a well-known scholar in the field of first and second language acquisition and developmental disorder and grammatical processing in psycholinguistics. There are so many things to say, but we don't have enough time. So I posted his short CV and his website in the chat window. So when you want to get more information, please visit there. Okay. And today, Dr. Clausen is going to present his talk titled Morphological Constraints in Language Processing and Language Acquisition. So without further ado, please welcome Dr. Harald Clausen. No.
Hello, can you hear me? Can you hear me now?
Yep.
Yep.
Okay, thank you. And you can see my screen?
Yep.
Yeah? Okay. So thank you very much for this invitation and for going through this experience of giving a talk to a monitor. That's unusual. The general point I'd like to convey on this occasion is that it's going to be a very linguistic talk in a way, is that grammatical phenomena that at first sight look very simple and boring become interesting and revealing when we investigate them within bigger questions in greater detail. My specific case today is the formation of compound words like web surfer or whatever, teacup, which appears to be a very simple process of combining two or more words into a single lexical unit with the meaning of the parts being combined to form the meaning of the whole. But what I'd like to show is that even this simple looking phenomenon is not so simple, and that when we properly investigate it from a linguistic and an experimental perspective, it will reveal general insights into core systems of language and mechanisms of language processing and language acquisition. Okay, so let's start with some linguistic background. Morphological systems are constrained in how inflectional, derivational, and compounding processes may interact with each other. There is, for example, a general tendency for inflectional suffixes to attach outside derivational ones across languages. This is captured in Greenberg's Universal 28, according to which derivational suffixes usually occur inside derivationals, inside inflectional ones and not vice versa. So in English, for example, forms such as ducklings with the plural suffix appearing after the derivational suffix are fine, but not the reverse, ducksling. So that's in line with Greenberg's constraints, universal. Linguists have analyzed the interaction between different morphological processes in terms of constraints or restrictions. So one of them are affix-specific selectional restrictions, and others are more general grammatical constraints, semantic, phonological, morphological ones. In English, for example, the observation that the denominal suffix e, as in ducky, never attaches to an already suffixed word, is an example of an affix-specific selectional restriction, so that you can say ducky but not ducklingy. A more general, an example of a more general feeding constraint, so having to do with interactions between these components, holds that regularly inflected forms such as S plurals are blocked from productive derivational processes. So you can say duckless, but not ducksless. And in the psycholinguistic literature, one of these more general constraints has become very famous, which is the having to do with the plurals in compounds effect in English and other languages. So what's meant by that effect is the fact that lexical compounding is constrained in that regular plurals are dispreferred as non-heads inside compounds. So you cannot say cow's eater in English. You have to say cow eater. While irregular plurals are marginal, and in German, for example, fully acceptable. So you can say, well, with a question mark in English, oxen eater, you would prefer to say ox eater. But oxen eater is definitely not as bad as cows eater. So we get this three-way contrast. That's basically the plurals in compounds effect in English. And this plurals in compound effect is not unique to English. We find it in other languages as well. So for example, in German, only S plurals are banned from appearing inside compounds, whereas all other plurals are permitted. So you cannot say Autosfabrik, car factory. This is ungrammatical in the same way in which it would be ungrammatical in English. But you can have all sorts of irregular plurals inside compounds. So for example, a word list in German can be a Wörterliste, which is the plural of that word, or the singular form. Note also, which is something we will come back, that both English and German allow infixes, S infixes inside compounds. So they are called linking morphemes. So for example, this is I love that example. This means love sickness. And the first non-head element is the word love, which doesn't have a plural. There's no plural form for that word. It's just love. And this S is not a plural, but it's a linking morpheme. So there are phonologically no constraints on having S inside compounds. It's just when it's a plural, then this is bad. Likewise, in Dutch, to give you a third language, you can say appelsboom, which is the plural of apple. You cannot say this. This is ungrammatical, like in English and German, but you can say Persikenboom, which is the plural of peach, this en plural here. So S plurals are also banned in Dutch from inside compounds. It's not that S is banned from inside compounds, as you can see here. The same with English. You can say huntsman and bondsman, etc. with this S inside compounds, no problem, but plurals not. Okay. There are indeed numerous psycholinguistic studies on this effect. This is perhaps one of the best studied morphological effects in psycholinguistics, this plurals in compounds thing. So we have different populations, children, adults, etc., different modalities, and using offline and online techniques, as you see here, and on different languages. And in this talk here, I will review some of these studies and show that they have produced remarkably consistent and replicable findings. So the facts, that's a nice kind of state of affairs. The facts seem relatively clear. There's not so much debate about the facts, but there is debate about how we interpret these facts. And that is progress in science, if we are not just talking about the facts, but if we have competing interpretations and theories. Okay, let's move into this a little bit. There are two contrasts that need to be explained. Well, yeah, sorry. There are two contrasts that need to be explained. Firstly, that bare singular forms are preferred over over plurals inside compounds, and this is uncontroversial. I come back to this. And secondly, that S plurals are disliked from inside compounds, and this is controversial. Okay, so the explanation for why singulars are preferred is not controversial, but the second one is controversial. So let's talk about the controversial one first. Two alternative proposals have been made with respect to the observed dislike of S plurals inside compounds. Firstly, a morphological account. So this goes back to Kiparsky, who proposed a level ordering kind of model, according to which regular inflection applies after other morphological processes, such as irregular inflection, derivation, and compounding. So in a way, regular affixes come too late in this kind of series of processes to be applied inside compounds. You first produce a compound and then you pluralize the whole compound, but not the elements within the compound. So he explained that in this kind of serial level ordering kind of model. There are other linguistic proposals by Jeju and Williams, for example, who claim that lexical compounds prefer to join stems rather than words. So elements that are stored in the lexicon, like irregular plurals, are considered to be stems, while regular plurals are combinatorial results of combinatorial processes and are words. In any case, what is common to these ideas, Kiparsky, Jeju, and Williams, is that the dislike of S plurals inside compounds is morphological in nature and not due to any kind of surface forms. That's one account. As an alternative, it has been suggested that the ban on S plurals inside compounds is due to a surface form constraint, in that non-heads should not have the phonological form of a typical regular plurals. So they should not have any sibilant codas. So this is a proposal by these guys here, Haskell and others. They observed that pluralia tantum nouns, for example, pliers rack, right? Or trousers are kind of marginal. They are marginally accepted. And that words like or tweezers box, right? They resemble phonologically plurals, but are semantically singular. And are only marginally acceptable inside compounds, and that these items are often reduced to singular forms. So there is, you say trouser press, right? Even though this is a pluralia tantum noun, and there is a pop band some years ago, I guess. They call themselves scissor sisters, right? Reducing the S inside compounds. So that so if this was a morphological constraint, there's no need to say scissor sisters or trouser press, and there's no explanation for why this is unacceptable. So they say this has a surface explanation and this morphological constraint is not needed. Okay. So this is the controversy concerning the S plurals. Now, whatever the appropriate characterization of the dislike against S plurals inside compounds, the preference for singular forms and the corresponding dispreference for plurals, irrespective of regularity, also needs to be explained. And this has been attributed to a semantic constraint, according to which the non-head element, and this is not controversial, I think, according to which the non-head element of a compound denotes kinds rather than individuals. So as such, they are not referential and therefore do not typically encode a numeral quantity as a feature. So for example, take the compound handgun in English. Handgun. The non-head hand does not refer to a hand or to multiple hands, but only to the manner in which the gun is used. Okay, so that's why the singular forms are concerned. Note, however, that in English, the singular form of a noun is identical to the bare nominal stem. There is no singular affix. Hence, there is some ambiguity as to whether the preferred form inside a compound for the non-head is actually a singular form per se, or whether the preferred form is an unmarked form that's unmarked for number. That would make a lot of semantic sense if it was unmarked for number. In English, you can't tell. So we have to look at other languages. So imagine a language that marks the singular with an affix. It's unmarked. Okay. then one should find that plural forms are preferred over singular forms as non-heads inside compounds because they are unmarked. And in fact, such a language exists. I mean, I know of one, Welsh, where nouns may take singular forms that are marked with a suffix. Okay, so here's a suffix. That's the word for pig. Don't ask me how to pronounce this. And the singular form is, the plural form is unmarked. And now, if we look at compounds, we would expect that actually the plural form, the plural in inverted commas, appears inside the compounds, the compound. Okay, and it does. Right? We find this form inside compound, but not the singular form. So what counts for this semantic constraint is what the unmarked form is, and not singular versus plural. Okay, now let me explain why this plurals in compounds effect, at the moment you may think this is a marginal thing, why it has become so famous. This was, I guess, largely through Steve Pinker and others, who said this is a case in point for the poverty of stimulus in language acquisition. Pinker referred to a very influential experiment that Peter Gordon did in the 80s, and in which he found that there is a contrast between the input a child receives and the things the child produces. So the input a child exposed to in English, for example, essentially contains a two-way contrast, namely the child hears bare singular compound modifiers basically all the time, but very, very few, if any, plural compound modifiers. So what the child hears is rat and mouse eater, but not mice and rats eater. On the other hand, when Gordon did his experiment, he found a three-way contrast. And this has since been replicated many times. So 3 to 5 year old children, young children, allow irregular plurals inside compounds, but consistently omit regular plurals from inside compounds. So they say rat and mouse eater, and also mice eater, but they don't say, never say rats eater. Okay? So children, this is what Pinker made out of this, a product of the innately specified architecture of their language system. He said this is a prime case of the poverty of stimulus argument. Children come equipped with these constraints, and that tells them you can do you can produce these two types of compounds, but you must not produce this compound, this case. Okay. And this provoked some response from people who don't like innate constraints. There is a series of studies. I just picked one from Ramsgar and colleagues, and they proposed an alternative explanation. So Ramsgar note that singulars are preferred inside compounds by children and in the input, and that the irregular plurals they sometimes produce are actually experimental artifacts of the kind of experiment Gordon made, and they are not taken. They are not to be taken seriously. So the point is that Gordon used an elicited production task, and Ramsgar argued that this task prompted children to overproduce plurals, irregular plurals, they would normally not produce. So in Gordon's experiment, children first see a picture, and the experimenter says, this is a mouse, and then they see another picture, and the experimenter says, these are two, and then the children have to say the plural form. And then the children are shown a monster of some kind, and the children are asked, and what do you call someone who eats up all the mice? And then the experimenter repeats the plural form the child has produced. So if the child said these are two mouses, overgeneralization, the experimenter would do the same. And Ramsgar argued that the production of irregular plurals, the child produces this plural himself or herself, and is repeated by the experimenter, that this produced a production priming effect. So the procedure prompted them to produce an to maintain this irregular plural inside the compound, even though they would normally not do this. This is an experimental artifact, they would say. Then why don't children produce S plurals inside compounds? Well, because of the surface constraint that I illustrated before, that I mentioned before. Children don't like S's inside compounds that could be plurals. So Ramska and I conclude, children learn interactions between plurals and compounds via statistical induction based on environmental patterns of language. No use for any kind of grammatical constraints or any kind of innateness argument, right? So you can see that this little phenomenon has impact on lots of things in big questions, and I wanted to get into this a bit more. So this is an outline of the rest of the talk, if this moves on. Yeah. So I will mainly review studies on English with occasional detours to German. Firstly, a number of results from acceptability judgments tasks to determine the nature of the compounding constraints. Then I will look at some eye tracking experiments, and if there is time, I will look at ERP studies as well. So it's a lot of stuff. Let's see. We ask the question that you see here: how is offline performance affected by the compounding constraint? A non-morphological account would predict that singular forms that are phonotactically similar to regular plurals should be somewhat less acceptable inside compounds than forms that do not have sibilant final codas. So, for example, something like fox chaser should be less acceptable than wolf chaser. So we performed experiments in English and in German on this thing. And here you see the references where they were published. This is now published all. We had 3 groups of participants for the 2 experiments on English, a control group of 32 adult L1 speakers plus 96 English children between 7 and 12, and 44 advanced second language learners with L1 German who were highly proficient in English were tested. And in German as a target language, we didn't have any children. We had 33 adult L1 speakers of German and 33 advanced L2 learners with a Slavic language background. Here you see they were very advanced. Here you see that they were real L2 learners with AOA of 13. And yeah, all right. And here's the procedure. Let's see. For this task, participants were familiarized. Remember, we wanted to do this with children as well, so it's a bit childish for an adult, but never mind. They were familiarized with Mia. This is Mia, a cartoon character who is from China and just came to England to learn English. She sometimes makes mistakes, and participants should help and correct her. That was the instruction given to them. Then they were shown a picture whilst listening to the corresponding auditory stimulus, which sounded like this. Let's see.
This is a monster that likes to eat rats. Mia calls it a rat's eater. How does rat's eater sound to you?
All right. I hope you could hear this. Could you hear this? Can I get some feedback? No? Are you still there? Yes. Okay. Thank you. I saw the chat. All right. So then after hearing this, they were asked to rate the acceptability of these plural forms inside compounds and their corresponding singular forms on a scale from 1, very bad, to 5, very good. Note yeah, that we deliberately used a judgment task rather than an elicitation production task. Because if, as Ramsky and I speculated, children's own production of irregular plurals inside compounds is an epiphenomenon associated with priming, is an artifact in the elicitation method, then children are expected to perform differently when asked to make judgments. According to Ramsky and Dye's account, children should show the same behavior for regular and irregular plurals and just copy what they get in the input, namely disfavor the inclusion of either one inside compounds. So this is the German version.
This is a monster that likes to...
This is the German version. It's basically the same. Right. Is it Paprikasfresser and Paprikafresser? Okay. Okay. Here are the materials for the English experiment. Item set 1, the ones on the left, manipulate the morphological properties of compounds of non-heads inside compounds. So you get regular, irregular, plural nouns and corresponding singular forms. And item set 2 manipulates the surface form properties of the non-head. So whether the non-head ends with has S or Z, sibilant coda, or a non-sibilant coda. So something like bag versus box, or cow versus horse, etc. The critical pairs, for example, duck and goose, yeah, a duck and goose, or a bag and box, were matched for length, frequency, and also with regular. Yeah, is everything all right? The host, yeah, okay. So you can hear me, okay. Yeah, well, I got a message from Zoom that something was happening, but as long as you can hear me, that's fine. So you can see if you compare these numbers with these numbers and these numbers, what we get is a three-way distinction, right? They don't like regular plurals inside compounds, and they like regular plurals and irregular plurals inside compounds, right? This is very clear, and there is statistical analysis for this which confirms that. Then look at item set 2. Remember, this is fox versus wolf chaser, right, or something like that. And you can see no difference. There is no difference between these two types of compound. Okay.
Harald,
So,
I think you have
sorry.
to share your PPT PowerPoint.
I did. Sorry.
Reload.
Something happened. Yes.
Right.
Okay. I go share screen. Oh. But you could see my screen before, right?
Right, before, but it's gone.
No. Something has happened.
Right.
Okay.
Do
you see my screen now?
Yes.
Did you see this before? Did you see this table before? Hello?
Maybe can you go over this? Yeah.
Okay. I go over this again. Okay. So these are, remember, we had these two item sets, right? This was manipulating the singular versus plural morphological properties, and this was manipulating the surface properties, whether there is a sibilant final coda in the non-head or not, right? You saw this before. You saw this before.
Yes.
Okay, and that's just the same thing for German. Now, these are the results. So what you can see is item set 1. These are the 3 types of morphological non-heads inside compounds: regular plurals, irregular, and singulars. You can see a 3-way distinction here. The singulars are highly acceptable, and the irregulars as well, sometimes a bit lower. And the regular plurals are dispreferred. They are significantly rated worse than the other ones. And for the item set 2, this is testing the surface constraint. There is no difference. There's no difference between the two, and this was also statistically confirmed. So this shows that the participants are sensitive to the compounding constraints, and that the dislike for regular plurals as non-head in compounds cannot be attributed to any kind of surface property. Okay, so Ramsky is wrong. And that is the same for German. Again, we can, there is no irregular plural here because they are acceptable. The results were parallel to those for English. Both L1 and L2 participants accepted compounds with non-heads ending in non-plural S segments as fully grammatical. There is no difference between these two. But they rate regular plurals inside compounds significantly worse than singulars. So again, no way that this has something to do with surface constraints. So what we have seen is that these people that we investigated, children and adults, and also L2 learners, are sensitive to the compounding constraints offline. In addition, it shows the results show that ratings of acceptability were not accounted for by superficial phonological properties of the non-heads. So this is in contrast to what Ramsky and Dye said. So in other words, it was the morphological constraints related to regularity of inflection that accounted for the results and not some kind of phonological property. Also note that this was a judgment task rather than a production task, different from Gordon. So Ramsky's attempt to attribute children's irregular plurals inside compounds, so why they say mice eater, as an experimental artifact of production priming can also be rejected. It is simply hard to see how children can learn these compounding constraints from statistical analysis of the surface forms in everyday life contexts, because these forms do not really exist in the input, these irregular plurals. Still, children find them appropriate. Okay, let's move on to language processing. So we are now looking at the time course of the compounding constraints, not offline, online. They have been extensively studied offline, but their role in online processing is unknown until we did some studies on this. And our theoretical background for this, for these online processing studies, actually comes from sentence processing research, where we are confronted with 2 general models of the time course of, let's say, syntactic constraints. And we just extended this to the morphological constraint. Okay, so one possibility would be that the morphological constraint inside the grammatical constraint has an immediate effect on processing, whilst the semantic constraint against irregulars only affects later stages of processing. That would be compatible with structure-first accounts of language processing, according to which the initial stages of processing are purely structure-driven, and non-structural information, in this case semantic, and contextual cues are processed later. So this would be some kind of 2-stage theory. Frazier, etc., many others argued for structure-first accounts in sentence processing. That would make this prediction. The morphological constraint affects early stages, the semantic constraint later stages. So we get this kind of effect. An alternative possibility propagated by many sentence processing accounts, constraint satisfaction theories of language processing, would say if everything is processed in parallel. So there shouldn't be any difference between early and late measures. We would expect to find these constraints to affect early and late stages. All relevant information sources are extracted and used the moment they are received in the input. So this is a general, sorry, I have to drink. This is a general debate in processing literature that we try to address with this study, eye movement study. So we used eye movement during reading, and we tested 28 participants. They had to read short paragraphs containing novel compounds. That was crucial. Novel compounds, such as those shown here underlined: lice remover, slugs remover, flea remover, something like that. The participants were instructed to read these sentences silently. You can just go through one of them at their normal reading rate and press a button once they are completed. We measured reading times throughout the sentence. They were also given a task. They were given content questions afterwards, but that's not so important. The crucial measure is the reading time on the head noun, on remover. That was the same word throughout conditions. And on the word remover, we would expect to see effects of the different types of non-head, right? And here is an example. You can see here what you can see in the next slide. I hope you can see this in the video, what we actually measured. What you see, the purple circle hopping around now, this is one of the examples that was actually shown in the way it was actually shown in the experiment. And you can see here the fixations and regressions that went into the analysis. This is our measure. So you can see how the eyes move forward, and sometimes they look back, have regressions, right? And this, did you see what happened at Owl's breeder? Yeah, the subject went. I could just watch at what happens at Owl's breeder. That's a critical word. And you can see that the eyes go into owls and then go back, right? So this is checking or whatever, right? Now move on. Okay. And here you can see the results. You can what you first see here is the results from an early eye movement measure, gaze duration, on the head noun. So this is gaze duration on the head noun of the compound. Gaze duration sums all fixations on a region, in this case the head noun, starting with the first fixation when the eyes enter the region from the left, up until the eyes first leave that region. So this is considered to be an early measure of eye movement. And the 279 mean gaze duration for head nouns of compounds containing regular plurals was significantly longer than both the 250 gaze duration for head nouns of compounds with irregular and with singular non-heads. And there was no difference between irregular and singular. Okay, so the regular, at this early measure, the regular plural sticks out. Now, this is a different measure. This is rereading times. Rereading times on the head noun are calculated by summing the duration of all refixations within a target region, within the head noun here, after it has been exited to either the left or the right for the first time. So this measure does not include initial time spent viewing a region. It's different from gaze duration, and it's believed to reflect later second pass stages of processing. Now, what you can see is that the rereading time was longer for head nouns of compounds containing regular plurals in comparison to singulars, but also for head nouns containing irregular plurals compared to singulars. There were no significant difference between the two. Okay. Now, finally, the third measure is total viewing time. Total viewing time is a composite measure, which is the sum of all fixations within a region, irrespective of whether they were early or late. This is a general measure of whatever difficulty and effort. And the graph shows differences between all, we get a three-way distinction, differences between all conditions, shortest total viewing times on singulars, longest on regular plurals, and in between the irregulars. In a way, what we get here is the three-way distinction we also get in offline experiments. So here's a summary of the results. I don't have to go through everything. So the initial stages of processing are sensitive only to the morphological constraint. The first graph I showed you with the gaze duration is basically showing the operation of the morphological constraint. The later stages of processing were affected by the semantic constraint. This shows the semantic constraint live, right? And we get the three-way pattern due to influence from both early and late constraints in the total viewing times. Okay. So compound processing appears to involve these two stages: an initial stage at which the compound is decomposed into its morphological constituents, head and non-head, and a later stage at which the head noun is semantically integrated with the non-head to form a fully specified compound meaning. The elevated gaze duration, the first graph you saw for head nouns of compounds, indexes the detection of a structural anomaly during the initial stage of parsing. Violation of plural number semantics with the irregulars, on the other hand, appear to be detected at a later semantic integration stage, as indicated by the longer rereading times. So it was not the case that I would take these results to mean that the constraints do not operate in parallel. They operate sequentially, with the structural constraint operating first. So, this is kind of supporting or in line with structure first models of sentence processing. So if I have time, and I think I have, I could also introduce you or present to you the ERP experiment. Is that okay? Hold on, can I do this? Hello? Yeah, I guess I can. So we examined children's and adults' ERPs during the production of compound words. And we wanted to come up with a technique that actually works with children, that can be used with children. And we wanted to come up with a technique of using a design for using ERPs in language production. So far, this didn't really exist. Previous studies on using EEGs have used violation paradigms, which are not so nice in my view because they require metalinguistic judgments, and a production task would be a lot more appropriate, particularly for children. So in a series of experiments that we've been doing over the last few years, we experimented with the silent production task to examine the electrophysiological activity in the brain recorded with for visually presented stimulus words. And there is a whole pile of studies where we use this kind of technique. So here is what it looks like for the compounding task. So prior to the experiment, participants are trained to silently produce a compound from a visually presented verb phrase. So they are given a verb phrase like to feed duck. And in practice trials, they are told to form a compound like duck feeder out of this. And once they can reliably do this offline in the practice phase, they go into this ERP experiment. Each trial started with a fixation cross in the center of the screen for 200 milliseconds, followed by the visual presentation of a verb phrase. So we cannot do this experiment with 3-year-olds. They have to be able, the children that are tested have to be able to read single words or 2 words. So they have to be primary school children or school children. And this is shown for 1 second. And then the stimulus is followed by a blank screen with a jitter of 400 to 800 milliseconds in order to minimize influence of stimulus-related activity. To cue the silent production of the compound, a fantasy monster, this kind of character, appeared on the screen for 2 seconds. Then they are told, whenever you see this creature, say the compound to yourself silently. Don't articulate it. The silent production cue was then followed by a picture with a loudspeaker to cue overt production of the compound. Then they have to speak it out loud. Finally, a blank screen. The idea of presenting of this silent, you could say this is a delayed vocalization paradigm or a delayed production paradigm. The idea of the silent production is that body movements of your speech organs affect the EEG. So that's why we didn't want them to overtly articulate the compound while we were measuring the ERP. So we are measuring the EEG. The critical time window is this time when the monster is presented and they are keeping their mouth shut and their speech organs are not moving. They are kind of planning the compound they are then producing. And we wanted to have this overt production as well to check that what we measure in the in the EEG actually, we wanted to see what they actually were planning. Other people have used just covert production without an overt control. And
Harold?
was combined with, can you hear me?
Now we can hear you, right?
Could you hear the introduction to this slide?
Can you go back one more? On previous
You have to
slide.
repeat, yeah.
I have to repeat what I had to say about this slide?
No, that one, okay, but next slide.
This one, I have to repeat.
Yeah.
Okay, sorry for this. Okay. So we had nouns with regular plurals, nouns with irregular plurals that were somehow matched in meaning and length and frequency. And each of these of the 4 types of candidate non-heads, so yeah, singular, regular, plural, regular, singular, irregular, plural, irregular, 4 types, was combined with 5 out of a set of 16 different transitive verbs. So, for example, tickle, paint, chase, collect, etc. Remember, they were in the first in the screen. They were shown verb phrases with a verb and an object. Okay. And then from that, they had to produce, subjects were trained to produce compounds with deverbal ER agentive head nouns. So boy biter or man biter or something like that, okay? And that's possible for all these verbs to do that. In this way, 160 trials were created for 4 compound types with 40 items per type, which is enough for an EG experiment. And then we had also 100 filler trials on top. Okay. We tested 40 monolingual English children, 20 adult English speakers, and 31 advanced L2 speakers of English with L1 German. Okay, first of all, the accuracy data. So, you know, remember, in this experiment, we get 2 types of data, right? We get the EEG while they are planning the compound, right? That's the EEG data you see later on. And we get their overt response after the loudspeaker picture. So let's look at the overt response first. This table shows mean percentages of regular plural, irregular plural, and singular forms maintained inside compounds. So when it says 5%, this means they were presented with something like feed ducks. And then they said ducks feeder in 5%. Actually said duck feeder, even though they were presented with feed ducks in 95%. Okay, this is how to read the table. So when you look at this, the compound responses showed that when presented with a singular form like duck and goose, this was almost always included as a compound internal modifier, right? Of course, when you say feed duck, they say duck feeder, right? And this is how these high numbers come about. When the noun to be included in the compound was an irregular form, it was still mostly maintained, right? Less so by the L2 learners, but it was still maintained. And there's nothing bad about that, to do that. But a clear contrast emerged, especially for the L1 and the children and adults, less so for the L2s. Clear contrast emerged for the regular plurals. They are very often, almost always, omitted. Even though they saw feed ducks, they say duck feeder. Likewise, the adults. The L2s, I come back to this, maintain this in a third of the cases as well. But still, even, you know, the other way to look at the data is to look at within group comparisons. And all the groups showed a 3-way distinction, even the L2s. So high, in the middle, low, relative to the others. And the contrasts are just more extreme in the L1 people. This can also be, there's also statistics I can show you to confirm this. So this is what we expected in a way. Now let's look at the new findings. This is the EG. Now let us be absolutely clear at what we look at when we look at these plots. We look at what happens in people's brains when they see this monster. Okay, so they are supposed to produce silently for themselves a compound from this stuff. Okay, and we are measuring the ERP. The ERP were time locked to the onset of the silent production cue, so the onset of this picture. That was the 0.0. Okay. That's the 0 point here. So what we see here is an enhanced negativity for what we are comparing is the regular plural to the irregular plural condition, right? When they were presented with feed ducks and feed geese, for example. So what we see is an enhanced negativity. This is the adults, L1 for the regular condition from approximately 300 milliseconds onwards, mainly on fronto-central sites. For the singular condition, there was no difference between these two, right? And this is the children, the 2 child groups. We also see an enhanced negativity, but much later. Later, you know, it's also kind of frontal, bilateral, and it's later between 800 and 900 in the than in the adult group. Okay, but it's also significant, you know. And for the L2s, this is for the L2s, we again see this frontal negativity between 300 and 450 milliseconds. Again, as for the L1 groups, the control conditions in which the non-heads were presented as bare nouns, so eat rat versus eat mouse, did not produce any reliable difference. So what we found was in the overt production a striking contrast between well, striking contrast. We found a contrast to the L2 group. So the children and the L1 adults perform pretty much alike. They showed this very low use of regular plurals inside compounds, but the adults had like 30% maintained. Okay, so they allowed these plurals more, but still the contrast was within the L2 group was still there. There was still a three-way contrast there. I put this uneven. It's not equal to here because of the 30%. You know, this is much higher than the numbers here. When we look at the EEG data, on the other hand, we find a contrast between the children, the children, and the two groups of adults. In the sense, with respect to the timing, all of them showed this enhanced negativity for regular plurals inside compounds, but this effect was much later present in the children. You know, this is what this does not equal to refers to. It was much later than in the adult group, two adult groups. The two adult groups did not differ, and they had this effect very early, and they were late. So that could mean that morphological processing in children is, you know, now we can try and interpret what this means. These differences, this could mean that these morphological constraints are not just as efficient as in children, more resource demanding, they need more time. That is kind of slower processing. And this kind of shows a gradual difference between the L2s and the L1s, I guess. But in principle, the effect is there. So let me wrap up. 2 more slides and then I'm done. Is that okay? 2 more slides?
Yep.
No answer. I guess so. So the results overall from the various tasks were remarkably consistent, as I promised. And I like to highlight 3 points. The judgments and acceptability judgments and the elicited production tasks I reviewed revealed a 3-way distinction between number and regularity. Singular forms were preferred overall. And when a plural was present, there was a greater acceptance for irregular plurals than for regular plurals inside compounds. Secondly, the data could not be explained by these superficial phonological surface properties. So it was the morphological notion related to regularity of inflection that accounted for the results, not some kind of surface constraint. Thirdly, we found that the compounding constraint against regular plural has an immediate effect on morphological processing, indicating structural information is used early during processing, and not only in sentence processing, but also in morphologically complex words. And so, you know, let's come back to this general point. I would conclude that the study of a linguistic system that at first sight might seem marginal and, you know, potentially bears on big questions. In our case, on these on 2 big questions. Firstly, I like to echo the earlier criticisms of the surface account and statistical learning accounts. In language acquisition, children directly learn the conventions of the adult language from the distribution patterns in the input. I'd say not really. That can't be right. And secondly, the idea of fully parallel processing of all information sources promoted in constraint satisfaction models, you know, everything is processed at the same time, is also challenged by our findings. We found that structural, in this case, morphological information becomes available earlier than semantic information. And that was seen in the eye movement and the ERP experiment. And this is more in line with structure-first models of language processing. That's it. Thank you very much for your attention.
Okay, thank you for the talk. I don't think he's listening. He can listen to it. Can you hear me?
Very badly. As I said before, you know, I can hardly hear you.
I don't know how can I manage it, but the audience.
Speak up a bit, if you can.
Audience, if you have any question, you can type your questions in the chat room, right? Okay.
Yeah.
So the first question that we are looking at is, I don't know how can I say to him, since he cannot hear me clearly.
Well, now
you can
better.
designate the question. I mean the questioner, yeah, the person who raised the question.
How were the test items presented, visual or oral? That was the first question, right?
Yeah, Dr.
Right.
Oh no.
Kim, can you open your microphone?
Hello, hi. Can you hear
Hi.
me? Hi.
Yes, I can hear you.
Okay, that's great. I'm not going to turn off the camera because I'm sort of early in the morning, so I'm on the other side of the globe. Thank you very, very much. You know, as always, it was a wonderful talk. And then I have two questions. The first one is about that ERP test design. I think it was slide number, I don't remember exactly, 35 or 36. When you presented that, the stimuli, slide number 35 or 36, somewhere there. I don't remember exactly.
Which experiment? The EEG experiment?
EEG, yes, the last one. Yeah, when you tested
EEG experiment.
Right.
Yeah, no, let me bring up this slide.
In the meantime,
okay.
I would just ask the question because
yeah, go ahead.
The example you showed was
this one, yeah?
Exactly, yes, yeah. So you have that example, feed duck, but the cartoon that follows, I was a little bit surprised because in my mind, if I had to come up with that compound nouns, then when I think about like, you know, the duck feeder, I would come up with that kind of plastic bottle that, you know, when you feed ducks. So sort of, it's already like, you know, in my head, it's something like you have kind of whatever cylinder style duck feeder you feed. So when I see that cartoon, I would be a little bit surprised. Maybe as for some test items, I wouldn't, like man eater, whatever, some sort of other items, yes. But then certain items, I already have that kind of fixed mindset. So I'm a little bit surprised by that. So that was so did you think about that? That's my first question. And then I have another question.
Say something about this?
Yeah.
Okay, remember that I said the participants were habituated to this kind of task in a practice session. So this cartoon figure was the same for every item. It was just this item. And it was also used in the practice phase. It was just a cue, a visual cue to say, now construct a compound out of this. And they were trained for this kind of action. When they see this, they have to use these words and construct a compound. That was it. We could have used whatever, any other, we could have used a picture of Donald Trump here or anything. It was just a picture, child-friendly picture that was meant to be a cue for compound production in the same way that this picture was a cue for speaking it out aloud. Okay, so you wouldn't predict anything sort of like mismatch among different test items, you know? We didn't find any. We didn't find any. I mean, the results were very consistent. We didn't find any. This was just, you know, and we made sure before that we even started with the experiment that they could reliably produce compounds when they see this compound monster. This is a compound monster. Okay. Okay. Okay.
Fair enough. Okay, thank you.
No. Fine.
Yeah. My second question is more about, I really like the result, by the way. I really welcome the result. But my question is, if you compare that two different constraints about compound formation, morphological constraints, and then surface form, I definitely would go for morphological constraints. Yeah, but I mean, already biased. But nonetheless, I was wondering whether you would expect any difference, especially lower level L2 learners, because obviously surface form, especially the test items are presented orally, maybe they only pay attention to the phonological difference. But because in order to distinguish between these regular, irregular, like forms and etc., you need to some extent certain knowledge in that target language. So I was wondering whether you would expect like low level L2 speakers may result to a different strategy. They first, like initial stage would be really surface form, but as their proficiency develops, maybe they result to morphological constraints, actually showing the opposite pattern.
The opposite pattern, I don't know. I mean, you actually saw some difference in my presentation between the L2 learners and the L1 learners. In the last experiment, for example, they maintained about 30%, almost 30% of these regular plurals inside compounds. And remember, the L1 children maintained 5%, right? So, and even though, and that was despite the fact that these adults were highly proficient in English. You know, these were students at the university here, and their English is quite good. And so, yeah, it could be that these constraints, you know, you shouldn't think of these constraints in, I mean, these results prompted us to think of these constraints as as graded constraints and not black and white constraints. So in the paper that presents these L2 results, we actually made use of graded constraints to explain to account for the differences we find here between the L2 learners and the native speakers. They show the same. They show sensitivity, the same pattern, the three-way pattern as the native speakers, but the constraints are less robust, I'd say, than in the native speakers. And then extending this, coming back to your point, you may imagine that the robustness of the constraints is even lower in earlier learners. So you can imagine that these constraints have less of an effect. But that doesn't mean that they are sensitive to the surface form properties. That's a separate question. It could be. So what I'm happy to acknowledge is that these constraints in L2 learners, particularly at lower proficiency levels, may be less robust than in native speakers. You know, they are not excluding as much, but we don't have any evidence that they are sensitive to these surface constraints. I don't think the surface constraint makes any sense for anybody.
Yeah, I like the results, by the way, but I was just like, you know.
No, it's an absolutely sensible question, and I'm just saying, you know, even with the results I presented, you see some evidence that you may be on the right track with this constraints being less robust.
Thank you very much. Thank you.
You're welcome. Anybody else?
Okay. If you go to the chat window, there's one question from Wonil Chung, and her microphone is not working.
Oh, so from whom?
From Wonil Chung.
There are some compounds.
Yeah. I have a question about using materials.
I see that, yes.
Yeah, written in one word, such as cockbite, babysitter, And I'm wondering whether L2 learners would process compound with the structure information if we use them.
I see. I see. So the question is about let's say let's say unclarity in English, that you sometimes write the two elements of a compound as separate words, and sometimes you write them together in one word. Okay, that is the question, and we don't know what, you know, it's hard to say when we do what, right? And okay, so that's the issue. That's the linguistic issue. When do we write? And the person is asking. So it's not so clear when we write this and when we write it separately. I'm wondering whether L2 learners could process compounds with structural information if we use them. So, and I don't understand that question. So that's the question. Is this a pedagogical question? So could they use could the L2 learners use the structural information, the constraints, if we write these words separately? Is that the question? I don't understand. I understand the linguistic issue, but not the question. Can anybody help me?
My understanding is if whether the L2 learners process differently, if they have the combined structure or if they have the space in between.
I mean, all the compounds we used. I mean, first of all, in the in the ERP experiment, there was no writing of compounds involved, right? You know, they were given feed duck and they had to produce a compound. Writing was irrelevant, doesn't play a role. They just had to say it. In the reading experiment, the eye movement experiment, all the compounds were written as separate words.
Okay.
So as you saw with owl, there was no single compound that was written as one word, because these were all novel compounds, right? And so there are some compounds in English, existing words that are written together, you know, like babysitter, for example, right? But if you use novel words, you wouldn't write them together, I guess. And in any case, we didn't for this experiment, right? Okay. And so I don't think this spelling, there is actually interesting research on this. There's eye movement research, you know, from another team that investigated how the different spelling affects the processing, the different, you know, whether compounds are written together or separately, how this affects processing. But this is a separate issue that was not manipulated in our studies. Okay.
Now, can you scroll down a little bit? And there are two questions from Ki-hyo Park.
Okay, I go back.
A little bit.
The first one, yeah, was the time during the silence queue enough for L2 participants to produce? Okay, in other words, have they produced the words with complete forms well, regardless of the accuracy? I'm quite new with this experimental design. Yeah, well, this is a new design. No surprise that you are new to this design. This is we invented this design, okay. So the question is, were they given enough time? So maybe the idea is the L2 learners were kind of disadvantaged. You know, it's an L2, etc. And they process more slowly. That's the background. And were they given enough time? This was 2 seconds. The time to, let's say, plan the compound, right? When they saw this monster was 2 seconds. 2,000 milliseconds. This is a lot. I would say they were given enough time, because if you look at the EEG, they show the same effect at the same time window as the native speakers, adult native speakers of English. And you children, because the children show this very much delayed effect, during the silent production phase. So in other words, have they produced the words with complete forms well, regardless of the accuracy? So this is an attempt to explain why they maintained 30% of the S's inside compounds, right?
Yeah.
Because they didn't have enough time to kill the S, so to speak, from their production, right? Is that perhaps that's the idea? Well, that's a possible speculation, but there is no strong evidence for that, given that the planning, to the extent that the EEG reflects the planning of what later on comes out of the mouth, then we don't have any evidence that the L2s were not given enough time, because the EEGs look like the native speakers ones, right? We could say this for the children, but it's a possible speculation, but I think there's not much evidence for that. Okay, there's another one. You can also respond to my response if you like. The other one, how about the languages such as Bantu that have morphologically rich prefixes, yes, that concord with a noun class, right? It seems the languages you've introduced are mostly pertaining to suffixes. Do you expect that the results with Bantu languages would be similar with English and German ones? Well, I don't know. There's no, no, I would say there's no, I wouldn't expect this. Why would prefixes make a difference here? This has something to do with the, the contrasts that we found have something to do with the mechanisms for forming complex words, right? Whether you have whether they are based on inflectional rules, and these inflectional rules may involve suffixes or prefixes, or whether you have, let's say, exceptions, stored items like oxen or children or mice that you store in memory and that you can feed into compounds. The point is, a form like rat's eater is not possible, because rats is a combinatorial form which consists of a suffix and a stem, and mice is an exception. It's just stored in memory, and that's why you can grab mice and feed it into a compound in the same way in which you can grab mouse and feed it into a compound. There's only this semantic constraint, and other languages like Bantu languages have prefixes, and within Bantu languages there may be regular combinatorial prefixed forms and exceptions that you have to learn item by item. And then the same contrast should apply. I don't see why this should just be restricted to suffixes. By the way, we recently did a study on Bantu with a PhD student, but not on compounds. This was on derivational and inflectional prefixes.
Okay.
I can give you the reference if you want. This is on another morphological topic, but it is on Bantu.
Okay. And there's another question from Flower. So Flower, if you don't mind, would you turn on your microphone and then ask the question directly? Because it's a little bit difficult to guess what you are asking. Flower? Oh. Floor. Babysitter, babysitters. What would you like to ask?
Hello?
Yeah.
I don't hear anything. Flower. Flower? This
babysitter or babysitter. It's a little bit difficult to understand. No.
No questions.
Or can you take Kim Gi-taek's? Yeah, Gi-taek Kim, Professor Kim Gi-taek's.
What can I do?
Kim's question first.
Okay. Can you turn on your microphone so
Okay. Head on. Shall I? You have a question. Some of your previous research showed that.
Yeah.
Shall I read that?
Okay.
Or you say it, or you?
Yeah, your previous. I remember that there's some fundamental difference between L1 versus L2 morphological processing.
Yeah.
Particularly ERP comprehension study. But here your ERP production study of compounding shows that there's no difference between L1 and L2. You only show the difference between child L1 and adult, right? So
That's right.
what would be some theoretical implications of this difference? Is it difference between comprehension versus production? Or
No. I think, I mean, I can only speculate on that. So when we do this, I can actually generalize this. So we did a number of these ERP studies comparing also L2 and L1 using this silent production paradigm with different phenomena. And we basically find that in all these studies, there's no difference between the L2 and the L1. So the L2s are doing the same. You know, the only difference we found is a difference between children and adults. Children are slower with this. Then they show the effects delayed. L1 children. And L2 adults are like L1 adults. So this whole issue of L1 versus L2 differences doesn't apply to this ERP effect that we found here. Okay, what could this mean? You can only speculate about this. I think what it could mean is that this negativity that we see here is part of a more general, perhaps even non-linguistic effect. Okay, and does not have much to do with subtle linguistic details, right? So this negativity is also found, this effect that we see here is also found in studies of bilinguals, when you study proficient bilinguals, when they switch languages. So in switching paradigms. So when you give them tasks where they get whatever the first word in a sentence in one of their languages and then the next word in another language, and they have to switch between languages, then you find this anterior bilateral negativity. Okay, so I think you know, this is of course a speculation. I think this reflects control processes more of a more general cognitive kind that are applied here to these compounds. In a way, you know, if you think about this in terms of control processes, you know, then you get like a conflict between what you are exposed to in this ERP experiment. You get feed ducks, and then your system has to say, no, don't copy this. You know what goes on in people's mind when they see feed duck and they are asked to form a compound is they think, oh, I mean, I have to reverse the order, right? It's duck feeder and not the order in which the items were given to me, right? And then there is a conflict between the item that was presented, you know, ducks, and the item they have to produce, duck, and that is in some very abstract way perhaps compatible with switching languages. And in any case, in both circumstances, we get the same ERP effect. So the reason, to answer your question, the reason that we don't find L1, L2 differences in this series of ERP experiments has, I think, something to do with the fact that the ERP reflects more general cognitive processes.
Okay, so can we take just one final question?
Of course.
From
Kim Gitek, actually, Professor Kim Gitek. Yeah.
Okay, so it was very interesting. So thank you for your excellent presentation. My question is as follows. So as far as I know that your previous studies only looked at the three-way comparison between L1 others, L1 children, and L2 others. However, some scholars, for example, Professor Barney D. Schwartz, claim that it is important theoretically to look at L2 children in addition to L2 others. My question is that I wonder whether you have any plan to look at L2 children in your future studies, and if so, I wonder you have any prediction about the L2 children with this population. That's my question.
Yes, I mean, we for the series of studies that I presented today, we didn't look at L2 children, and I'm aware of Bonnie Schwartz's ideas, and for other phenomena, we have looked at L2 children, right? And we normally look at different groups of L2 children, and namely at early bilinguals, so children who grow up with the two languages from birth, simultaneous bilingual children, and sequentially bilingual children. And these sequentially bilingual children are those that are that Bonnie Schwartz would call L2 children, right? And what we find in these studies, so we have published a study, for example, recently in the Journal of Child Language on bilingual children. What we find there, also an ERP study on something else, past tense, I think this was. What we find is age of acquisition effects, right? And this would be also something I would predict, right? Age of acquisition effect. So when the age, what matters to a child acquisition of two languages is the age at which the two languages come in. When they come in before the age of 5 or 6 or something, we basically get similar patterns to monolingual children in the two languages. We found this with also with EEG studies. And when these children, when the second language comes in after the age of 7 or so, we find differences between the monolingual controls. So I would say the interesting comparison when you look at children, the interesting issue is not to compare them with adults. The interesting issue is to manipulate or test the role of age of acquisition.
Okay.
And in that sense, adults, that they are adults and are allowed to vote and go to the military, etc., is pretty irrelevant for language acquisition. I think what's more relevant is the age at which they learned the language. And in a sense, these adults, that we test are also sequential bilinguals, right? They first learned one language and then learned another. And then the interesting comparison is within children, so keep everything the same, test children, all children, but manipulate the age at which they learned the second language. Did they learn it from birth, or did they learn it from at a later age? And in this study, we made use of this huge, large population of Turkish people here in Berlin, where we get all these bilinguals. We get people who learn German and Turkish from birth. We get people who just learn German when they go to kindergarten, and again later when they go to school. We get all these people, and they all live in the same environment. So we can keep the environmental conditions relatively constant and just look at effects of age of acquisition. And we have 3 papers in the journal Language Acquisition on these age of acquisition effects. Sorry, that was a long answer.
Okay, thank you very much.
I think it's time to wrap up. Okay, it was very nice, and thank you very much for your great talk, and thank you very much for all the audience for your active participation. Okay, and I think you have a good evening for Koreans, and you have a good day for Dr. Clahsen. So
wonderful. Thank you very much, and thank you for your attendance. I hope the talk was clear. I may be wrong in everything, but I hope I was clear in presenting.
Okay, thank you. If we have any further question, I think he will welcome to receive emails from us. Okay, so
I didn't hear that. Sorry, can you say that again?
I just made a sort of like a funny talk. So if we
Ah.
have any fun additional question to ask you, then we may send you an email.
Of course, of course.
Thank you. Okay.
Okay. Thank you very much.
Right.
We should say goodbye. Thank
Goodbye.
you. Yeah.
Goodbye.
Goodbye.